Today we will be getting practice on solving systems of equations with graphing. So what I'm going to do here is I'm going to work us through a couple of examples, kind of talk us through some of the things that we'll need to be looking for as we're trying to complete these problems. Now keep in mind, when we're solving systems of equations, we're looking for the coordinate point that both of these lines contain. So the spot that both of these lines cross through. And there's only going to be one if these lines are to cross over. And then we saw that there's also a case where we can have zero solutions if the lines are parallel, or we can have infinite solutions if the lines are the exact same. So we'll be on the lookout for that. But if there is going to be a solution, it'll just be one spot. So let's get started by graphing these lines. Now I'm going to graph this first one here with the red dot by it. So when I'm graphing lines, I always think about y equals mx plus b. And this tells me the information I need in order to graph, where the number on the end is our y-intercept, where I start on the y-axis here. Alright, and then the number with x is our slope. In rise over run form, it tells us how far up or down to go, and then how far to the right we go to find another point. So with that information in mind, let's graph these lines. When I'm looking at this first equation here, I see that it tells me to start at 3 on the y-axis. So there's our spot right there. Now for my slope, it tells me to go down 5 and to the right 3. So I'll go down 5, 1, 2, 3, 4, 5, and we'll go over 3. Alright, so with these 2 points here, I can now connect these in, have our line. Now, I'm going to go ahead and connect these for us here. Now keep in mind that this line does keep going past these points. So we'll extend this line on out. Okay, so there is our first line. Now what we're looking for is where is our other line going to intersect it at. Alright, so I look at the second line and it tells me to start at a negative 3. So I'll put our starting spot here on negative 3 on the y-axis. And it wants me to go up 1 and over 3. Now when I go up 1 and over 3, I see that I have found the crossover spot. So as we connect these two lines here, don't forget to put your arrows on the ends of your line, because these lines do continue for forever. We have found our intersection point right here. So now what I need to determine is how far in the x direction did we go and how far in the y. So it looks like for this point here we went 3 in the x direction. So our x coordinate is a 3. Now I went down 2. So that would give me a answer of 3 comma negative 2, which tells me that the coordinate point that works for both of these equations is 3 and negative 2. So this is the answer to the systems of equations. Alright, so we've accomplished this. Let's practice one more and see another one where it works a little differently. Alright, so here's another one for us. Once again, we are graphing our equations in y equals mx plus b form. So we'll just follow similar processes to graph this. I'm going to look first to see where I start. I start at a positive 3 on the y-axis. Now, when I look at my slope here, it says a 4x. So we have a 4x here. Now we've been talking about how we need rise over run in order to graph another point. Now, in order to get a run, because we have our rise, it's the 4. Keep in mind that we can put any number over 1, and it doesn't change anything, because 4 divided by 1 is still 4. Now you may be saying, Mr. Carl, this is telling me to go up 4 and to the right 1. But that takes me off of my page, right? I can't go up 4 because it goes off our graph. So instead of just guessing and trying to put a coordinate point somewhere up here and being a little messy with our graphing, let's think about another path we can go. Another option is we can do the opposite of both of these routes. So if I go down 4 and to the left 1, it will also satisfy this slope. So if we start from our y-intercept and we go down 4, and we go to the left 1, it will give us another coordinate point for our line. Alright, so then we'll connect it here. some arrows on the end because it continues for forever. Now let's graph our second line. Get this out of the way for us. Our second line tells me that I need to start at a -2. Alright, so we'll start here at a -2. Alright, and now for our slope on this one, just tell me I have a negative x. Well, let's think about what that means, because we don't see a number with our x. But a negative sign really just means there's an implied or an invisible -1x. Alright, and the reason we don't have to put the 1 there is because if we just have a negative x, we all know that that is a -1x. We're saving ourselves some time by not having to write the 1. And then once again, I need to put this over a number so that we can be in rise or run format. We can always put it over a +1. So this tells me I can go down 1 and to the right 1 to find another coordinate point. Alright, now you may see it already, but when I connect these points with a line here, I see that our intersection point occurs right here. Right, here is our intersection point. Now we need to figure out what our coordinate points are, because that is how we phrase our final answer. Alright, so we always talk coordinate pairs in terms of x and y. So I'll say, how far did I go to the left? Well, it looks like a -1. Then we'll decide, okay, how far down did we go? Well, we also went a -1. So the answer for this system of equation is a -1 and -1, because that is the coordinate point that both of these lines cross through. And we saw yesterday, if we were to take this information for our x and our y, plug it back into our original equations, that it would check out. It would work for both equations at the same time. Alright, so there's two kind of straightforward examples. There's one more I want to look at here, and it's going to be number 4 off of our paper, and then we'll be able to try some of these on our own. Alright, here is number 4. And the reason this one's a little different is because my first equation doesn't have everything that we're accustomed to. Right? It just has a y is equal to a -1. Now, if we think about this in terms of y is equal to an mx plus b, you may see, hey, I'm missing this m and x part, which means my slope is a 0. Alright, the slope is a 0, so we'll talk about what that means. But my y-intercept is still a -1. So I'll start at a -1. Now if my slope is 0, that means I go, let's put this in rise over run format, I can go up 0 and to the right 1. If I go up 0 and to the right 1, that just means I'm going to be running on a flat line here, which makes sense, because if we know that slope is telling us how steep a line is, if you have a slope of 0, that means you're just on perfectly flat ground. Alright, so this is what our line will look like. That's what a line is when it has a slope of 0. It's perfectly flat. It goes through the y-intercept that it tells us to. In this case, it was a -1. Alright, now our second equation will work just like normal. It tells us to start at a +4. Then it wants me to use my slope of going down 5 and to the right 2. Alright, so as we go down 5 and then go to the right 2, we'll see that we intersect our line at this spot right here. Okay, so we'll add arrows onto the ends of our line. And we have found our intersection point right here. So once again, all we have to do is talk about the x and the y coordinate associated with this. We'll see that we went over 2, so 2 in the x direction, and that we went down a -1. So no matter what the equations are that they give us, we are just looking for where these lines cross over each other. The intersection point. Intersection point. So where the lines cross over, that is our answer to the systems of equations. So make sure after you do all of your graphing work that you're finding that point, because this is the important answer right here.